Sometimes one of the kind of like, trippiest concepts to pick up on is, what is a mole? What in chemistry, what does it mean when we say we have a mole of something, right? And it looks really confusing, but if we kind of boil it down, I promise it's no different than saying we have a dozen of something. So let's say I'm bringing a dozen, I tell you guys I'm going to bring a dozen donuts to class, and the first 12 people, let's say I tell you guys I'm going to bring a dozen donuts to class, and the first dozen people to come can get a donut. How many people would get donuts? How many donuts am I bringing, right? A dozen is 12, right? You know what a dozen is, okay? So a mole, not that different. We'll call it the dozen's cousin, okay? So it's just a unit, like a dozen, but instead of describing 12 of something, it describes a huge amount of particles. So we usually use the term a mole to describe very large quantities of very, very, very small substances. Okay, so we talk about a mole of oxygen atoms, for instance, right? So a dozen equals 12. A mole of something just means that we have 6.022 times 10 to the 23rd particles of something. That's all it is. Okay, I know it's a really weird number, there's a whole history behind that number, but just know that when we say we have a mole of something, we have 6.022 times 10 to the 23rd pieces of that thing. Okay, so let's take an example. So if we have a mole of sodium, we have 6.022 times 10 to the 23rd atoms of sodium in our sample. Okay, and what's cool is that we've set up molar mass to be equal to the mass of the element in grams. Okay, so if we have 6.022 times 10 to the 23rd atoms of sodium, we have a mole of sodium, it will be equal to this number right here, this atomic mass in grams. So if we have a mole of sodium, we will have 22.99 grams of sodium. Probably won't ever see a mole of pure sodium because it's highly reactive with oxygen and water, and it basically explodes when it comes in contact with them, but just for examples purposes. With a mole of sodium, we have 22.99 grams, and that means we have 6.022 times 10 to the 23rd atoms of sodium. That's all. But what if we have something that has multiple elements in it? Let's say we're working with this week's sodium hydroxide. Okay, sodium hydroxide is a really strong base. We'll talk about what that means to be a base in just a minute. But if we have a mole of sodium hydroxide, we want 6.022 particles of the molecules of sodium hydroxide. How much would that be? How much mass would that be? Well, we just add up. 22.99 plus 15.999 plus 1.008. Because these are the atoms that are in one molecule of sodium hydroxide. So we add those together, and we would have 39.988 grams. That's how much 1 mole of sodium hydroxide would weigh. Okay, so 1 mole again, 6.022 times 10 to the 23rd particles of sodium hydroxide. So the next idea is we can take that concept of a mole and we can now use it to do concentration calculations. So concentration is meaning how much of something do we have in a solution. Okay, if there's more of that stuff in that solution, it's more concentrated. If there's less of that stuff in that solution, it's less concentrated. Okay, so molar is very common when we're talking about concentrations of stuff. Okay, when we're dissolving it in water especially. So a molar, capital M, really just means we have 1 mole of something dissolved in 1 liter. Okay, so we'll have 6.022 times 10 to the 23rd particles of something per liter. Okay, so number of particles per volume. That's all that means. So if we wanted to make a 1 molar solution of sodium hydroxide, we would add 1 mole of sodium hydroxide, which we know weighs 39.988 grams, to 1 liter of water. Pretty cool. Okay, so molar is concentration. A mole is a measure of the number of particles. So let's try it. Okay, here's an example. Seawater contains roughly 28 grams of sodium chloride per liter. Okay, what is the molarity of sodium chloride in seawater then? What is the concentration of sodium chloride of salt in seawater? So we know sodium has a molar mass of 22.99 grams. Chlorine has a molar mass of 35.45 grams if we're to look at chlorine on the periodic table. So those together, 1 mole of sodium chloride would equal 58.44 grams per mole. So if we had 1 mole per liter, we would have 58.44 grams of sodium chloride per liter. We have less than that. We have 28 grams of sodium chloride per liter in seawater. So it's not a mole. We don't have 1 mole of sodium chloride per liter, so it's not a 1 molar solution. What is it then? So let's do some math. We know we have 28 grams of sodium chloride per 1 liter. We know that 1 mole of sodium chloride is equal to 58.44 grams. Okay, we've just rearranged this idea here, right? These grams can then cancel. And if we do this calculation, 28 divided by 58.44, that gets us 0.479 moles of sodium chloride per liter, which is our unit for molar. 0.479 molar solution. So this is the concentration of sodium chloride in seawater. Again, big M, just a concentration. That's all that means. Molar. Okay, let's try another one. We have 50 mils, 50 milliliters of 0.5 molar hydrochloric acid. How many particles, how many atoms of hydrochloric acid are in our sample, are in our 50 mils? Remember, this unit right here equals moles per liter. So we have our volume, and we know the concentration. Now we just want to get to moles and then convert that to particles. Okay, so we know we have 50 mils. That's our volume. We know that in 1 liter, there are 1,000 milliliters. It's just easier to convert it to liters because that's the unit that's used in molar. So those would cancel. This specific sample that we have it's 0.5 molar concentration. So there's 0.5 moles per liter. So these liters would cancel. And then what about mole? How many particles are there per mole? Remember, we want to know how many particles of hydrochloric acid do we have. So we have 0.5 mole. 1 mole is equal to 6.022 times 10 to the 23rd particles per 1 mole. Oh, look, those cancel too. That leaves us, once we do this calculations, 50 divided by 1,000 times 0.5 times 6.022 times 10 to the 23rd gives us 2.5 times 10 to the 21st particles of hydrochloric acid, particles of HCl, in our 50 milliliters. So again, that's a huge number, 10 to the 21st, that's huge. So there's a lot of hydrochloric acid in there, which is why we typically represent these as concentrations, 0.5 molar hydrochloric acid or 1 molar hydrochloric acid. Okay, I hope that helped. We'll be doing some molar concentrations in our lab, and yeah, just know it's like a dozen cousins. Dozen's cousin, that's all. It's just a way to represent a large quantity of particles.